guys, let's go. I want you guys to look at oxidation of alkene. Yeah? Page 18. Everyone have to note. Yes, page 18 on oxidation of alkene, guys. Let's go. All right, guys. So let's look at alkene. Alkene can be oxidized, right, by using a co-KMnO4. Okay, no, by using a KMnO4. I want you guys to highlight this. Only a KMnO4. Not a K2Cr2O7, but a KMnO4. Okay, which is a powerful oxidizing agent. Yeah. All right, guys. Now let's look at it. So we have two different conditions. The first condition that we have, right, it's a cold dilute KMnO4. Highlight the word cold, highlight the word dilute, cold dilute KMnO4. Okay, so guys, the first one we have acidified. Okay, dilute acidified KMnO4. So the keyword is dilute and acidified. Okay, so guys, if you have a dilute acidified, right, a diol is formed, yeah. So I can say that the purple solution is gonna turn colorless. And it's gonna convert alkene to a diol, remember that. Alright guys, now I want you guys to write it down. Okay, whenever we talk about oxidation, what is oxidation again, guys? So remember, yeah, oxidation, right, is just gaining oxygen and losing hydrogen, yeah. Okay, remember that. Oxidation is gain oxygen, lose hydrogen. That's it. Alright guys, now let's go. Alright guys, the first one, right, I just want you guys to draw this out. Okay, if I have an alkene, okay, and I add a H2O, and I add, okay, this is under cold dilute KMnO4. Alright, cold dilute acidified KMnO4. Okay, so guys, using KMnO4 cold dilute, an alkene is gonna turn into a diol. Guys, what is a diol? Diol is 2 alcohol. So you have one OH here, another OH here. That's it. Alright guys, next. I want you guys to get me the name. Okay, what is the name for this compound, guys? How? Okay, so for the name, okay, we call it as a, okay, this we have 2 alcohol, right? When you have 2 alcohol, we call it as a diol, remember? So 2 alcohol is known as a diol. So this we call it as a butan. 2, 3 diol. That's it. Hannah, who's Hui? Who's this? Oh boy. Alright, guys, next. Okay, guys, let's say if you use a hot acidified, this is okay. This is the another reaction that we have. This is the most popular one. Yeah, keyword is hot, concentrated. Okay, the moment you see concentrated acidified KMnO4, the same thing. The purple solution is still gonna turn colorless. Okay, and now your C double bond C, right, is oxidized completely. Yeah. Okay, C double bond C oxidizes completely. That's it. All right, guys, now let's look at the first example or first situation. Okay, I have a C11C. Okay, so let's say the first scenario, right, is carbon atom bonded to two hydrogen atom, yeah. So it does look something like that. Okay, when you have two hydrogen on one end, right, and if you were to oxidize it, all right, guys, remember, yeah, for a hot acidified, what we're gonna do, right, we'll break this completely, yeah, remember. The double bond is broken completely. Guys, let's look at it. What do you see on one side? So see, I have a C and a H and a H. I'm going to redraw it here, guys. Because I have a H and a C and a H, correct or not? This one also the same, right? H and a C and a H. I'll just write it here, H and a C and a H. Okay, so originally it was like that, correct? C11C, right? So once it's broken completely, oxidation means you're adding oxygen. So add one double bond O here and an O here to turn into a carboxylic acid. Add a double bond O and an O to turn into a carboxylic acid. Get me? Alright, please write down. Alright, guys. Eventually, right, once a metanoic acid is formed, metanoic acid, right, can undergo a further oxidation. So you can oxidize this compound further, and it's gonna turn into, you break everything. It's gonna turn into a CO2 and H2O. So final product is a CO2 and a H2O. So how many CO2? 1, 2, 2 CO2. How many H2O? 1, 2, 3, 4, 2 H2O. That's it. This is my final product. Get me? Clear? Understand? Alright, guys, next. Okay, the second scenario that we have, kid, when the carbon atom is bonded to one hydrogen and one alkyl. This is the most important part. One hydrogen and one alkyl. Alright, guys, I will show you a structural first. Okay, later we're gonna do skeletal together. Yeah. So, guys, a good example is a CH3 bonded to a C. Double bond bonded to a C2H5 and a H. And I decide to oxidize it. Okay, please write it down. Alright, guys, once we have this, right, okay, reactant. So again, when you're oxidizing it, that means you're breaking it completely. Remember, break this completely. Okay, so first thing is, let's mimic, look at this C. What is it connected to? One C, one H. So it's going to turn into a carboxylic acid for the final product. So I'm going to rewrite this first. Okay, I have a CH3 connected to a C, connected to a H, correct or not? Then there was a double bond earlier, connected to this C, then H, then a C2H5, correct? So I write a C2H5 here, connected to a C, connected to a H, correct? Am I right? So originally there was a double bond here, right? I just have to cut the double bond. Okay, no more double bond, and I just have to add a double bond O here. Because oxidation means you're adding oxygen. So oxidation means you're adding oxygen here. And this, we call it as an aldehyde. So 2-carbon aldehyde, we call it as ethanol. 3-carbon aldehyde, we call it as propanol. Clear? For alkane, straight to carboxylic acid. Okay, it's straight away to carboxylic acid as the final product. Has another line. Should I just cancel it? You can just cancel it. Okay, Yongshin, yes. By right, it will turn into aldehyde first. But the final product, guys, the final product will always be a carboxylic acid. So this ethanol, you see, I just have to add one more oxygen in between the H and the C. That will turn into an ethanoic acid. The same thing happens here. I just have to add one more oxygen in between, and it's going to turn into a carboxylic acid. So the final answer, it's ethanoic acid and the propanoic acid as my final product. Okay, so my final product is going to be a ethanoic and propanoic acid. Here for last page, the reduction I have not copied. Later I will show you. I'll show you later, yeah. Alright guys, please write it down. Alright, kid, any question? If no question, right, guys, I want you guys to do this question now. Okay, this time I'm going to give you a skeletal formula, guys. Let's go. Okay, I want you guys to look at this compound, and if I were to oxidize it under hot acidified KMnO4, I want you guys to start drawing the product. Please tell me what is formed. Guys, I want the final product, yeah? Yes, that's the oxidation cleavage, you're right. Okay, your teacher might call it as oxidation cleavage. Yes, it's the same thing. Alright, guys, now please get me the final answer. Anyone? Hannah. Alright, guys, for hot acidified KMnO4, right? What the reaction is gonna do is it will be broken completely. Get me? The C double bond C will be broken completely. Okay, so guys, let's look at this carbon. What this carbon is connected to? Please tell me now. Before that, there was a H and a H, right? If you see a carbon with two H's, it's gonna turn into what? CO2 and H2O. Get me or not? So this part is gonna turn into a CO2 and H2O. This one, CO2 and H2O. Alright guys, what about this? Where the carbon is bonded to? One carbon, that's it. And one hydrogen here, right? If it's one carbon and one hydrogen, it's gonna turn into a carboxylic acid. So guys, This another thing in, I'll redraw, you see? Cancel. Okay, so this thing is going to turn into a C11OOH. Carboxylic acid. Done. Clear? Know how to draw the product or not? Alright, guys, this is one of the hardest reaction, yeah? Clear. I'll give you more example later on, yeah? Okay? Clear. Alright, guys, now let's look at it. If a carbon atom is bonded to one hydrogen atom and one alkyl group, okay, so if you have one hydrogen and one alkyl, right, will always turn into an aldehyde first and turning into a carboxylic acid at last. So final one is always a carboxylic acid, yeah? Understand? Sure, how to name that compound just now? This one, this we call it as a methyl propanoic acid. Methyl propanoic acid. Methyl propanoic acid. 3-carbon propanoic acid, methyl group. So methyl propanoic acid. Okay. Gloriana, for the reduction part, please. This page, are you talking about this page or the next page? The next, okay, come. I done. Okay, now guys, let's go. Let's look at situation 3 first. Okay, guys, for a situation 3, okay, this is when we have a carbon bonded to 2 carbon. So guys, you see, this carbon bonded to one CH3, another CH3. Can see, it's bonded to 2 carbon right now. Okay, the same thing. This carbon is also bonded to maybe, okay, a C2H5 and a CH3. Okay, so right now, the carbon is bonded to 2 carbon. And guys, if I were to oxidize it, what do I get? Alright, guys, remember this, yeah? What is oxidation, right? Remember this. Oxidation, you just have to break the C double bond C completely first. Cleave it completely. Okay, then guys, let me redraw this out. You see, what do I see? I see a CH3 and a C and a CH3, correct or not? Just cleave it first. And the double bond is here. Then another one is going to be C to a C2H5 and a CH3, correct? That's it. Yes, Alright then guys, next thing is, please add in oxygen. Always remember, what is oxidation reaction again? Oxidation reaction means adding oxygen. So now, we can start adding the oxygen. So we can add oxygen here, double bond O, and a double bond O. That's it. So this will turn into a ketone. So this we call it as a propanone. The next one is known as a butanone. That's it. Done. Clear? Oh, good. Alright guys, now I want you guys to draw the product when I cleave this. Alright guys, draw this out for me. I have a skeleton here. And when you oxidize it, what are the product that you'll be getting? Please try. Alright, so guys, try this question. This question, if you can do it right, means you are very good in cleaving. Alright guys, your cleaving reaction, this is very popular, please. Okay, try it out, please. Try to cleave it and get me the final answer. Okay, you'll be getting two different products, guys, by the way. I go washroom. I'll be very quick. Okay, let me try to answer. Do you know how? Oh, yo, wrong. Almost 50% right. Guys, got answer, anyone? Hui yo, thank you, Sun Long. Is this Sun Long? This boy, I love you, man. Okay, thank you. Alright, so guys, you see, I can chop it here, why not? So if I chop it here, guys, you see, what I'm gonna do, I'm just gonna recopy this entire part. Duplicate over. And this entire part, duplicate over. Okay, so guys, now let's look at it. So this one is chop off already, chop here, chop here. So let's look at this carbon. Where is it connected to? One carbon, another carbon, correct or not? So if it's connected to two carbon, it's gonna turn into a ketone. Ayo, walao, ketone, right? So guys, what is the name of the ketone? 1, 2, 3, 4. We call it as a butanone. Thank you very much. You got it right. Thank you, Sun Long. You got it right. Well done. Alright, guys, last one. Next, what is this carbon connected to? Because you are cleaving here, right? Please tell me what is it connected to. 1C? Correct. What else? 1H, right? Okay, 1C, 1H is going to turn into a carboxylic acid. So double bond O, OH. So that's your answer. This is a 1, 2, 3, 4 butanol acid. It's a methyl 3-methyl butanoic acid. Well done. Thank you, Sunong. You got everything correctly. Well done. I'm proud. Huh? What do you mean by? Oh, aldehyde is a partial. It's midway. Get me? The final product is always a carboxylic acid. Aldehyde is formed first as an intermediate product. Alright, guys, you want a gay one, right? Okay, because my class, I always make the question very gay one. I'm gonna give you a gay one. Finally, if a carbon is connected to 0, it will oxidize to turn into a ketone. Now, a gay one is coming. I don't understand why the first one is a double bond O. Again, if it's two carbon, can see that if you cut here, carbon is connected to one carbon, two carbon, it's a double bond O in the middle. Can see that? Look at this carbon. It's connected to 1C, 2C. So which means double bond O. Can see right? C, 1C, 2C, double bond O. Alright guys, now I'm gonna give you a gay looking one, yeah. Please draw this gay looking one out. Alright guys, if you can do this, I'll be damn proud. Die lah. Okay, let's go. Okay, this is one of the elite question, yeah, guys. If you can do this elite question, right, nothing in the syllabus can kill you. Okay, welcome to a cyclic product. Alright, guys, let's draw it up. Please try. Yeah. Done.
Horrible.
Why? You have to have faith. Karen.
There's like a cyclic shape still remain.
Okay, the cyclic shape will be broken down. Okay, guys, the cyclic shape will be broken down, yeah. Remember, yeah. Okay, why is it so? Because we are cleaving here and we are cleaving here. Okay, so this question is quite difficult, like actually quite difficult. Show me. Ah, yeah, correct. Almost, but almost already. You almost get it right already. Just that your concept is not quite right.
H forms CO2 and H2.
2H forms CO2 and H2O. 1C, 1H forms carboxylic acid. 1C, 1H forms carboxylic acid. And remember this, 2C forms ketone. Okay, I will give you a hint. It will form all three. You get all three different compound here. Please try. All right, guys, let's go. I'll show you how to do it. So first, we break this completely. Okay, so guys, then when you break this completely, right, you have to find, okay, a way to label it. Okay, so maybe I can label it like that. Second, yeah. Oh my God. Okay, I can label it like that. You see, I have turned from 1, 2, 3, 4, 5, 6. Okay, so you have a 6 chain. And guys, you also have to break it here, yeah. Get me or not? So you have to break it to 1, 2, 3, 4, 5, 6. That's the longest. So guys, I'm gonna draw a 6 chain. 1, 2, 3, 4, 5, 6. Can see how? That will be my 1, 2, 3, 4, 5, 6. Okay, label down the number already. Okay, remember whenever you are doing a cyclic, right? A good trick is to always put down the number. So once you have the number, guys, the first one, please tell me what this will turn into. Carboxylic acid, because it's 1C, 1H, right? So carboxylic acid, draw a carboxylic acid on your first. Correct or not? Okay, guys, what is that on 2? That's a cockroach leg, right? Draw your cockroach leg. 3 has nothing. What about 4? 4 has this thingy. And guys, you see, when you break this, one more time, let's look at this. When you break this, what this will turn into? This carbon is connected to 1C, connected to 2C. So this carbon is going to turn into a ketone. So put a double bond O here. One more time, you see? 4, then connected to this Y, connected to this Y, and this will turn into a ketone. Okay, guys, what about this one? This connected to a 2 H's. So if it's 2 H's, it's going to be a CO2 and H2O. Correct. All right, then continue. 5 has nothing. What about 6, guys? What 6 will turn into? 6 will also turn into a carboxylic acid, right? Done. Fun or not? That's your final product. Okay. This won't come out in the exam. This is too hardly. But if you can do this right, nothing in the exam can kill you. Like legit, nothing in the exam can kill you. All right, guys. Now, please write it down. Once done, we are moving on. Clear? Any question? If no question, we are moving on to the last part already. Oh, good. All right, guys. Now, finally, we are moving on to polymerization. Okay, guys. Oh, let me tell you, yeah, alkene is the toughest chapter, yeah. Okay, like really the toughest is alkene. Once we get alkene done, remaining chapter are way, way, way easier. Like super easy already. Okay, guys, let's look at addition polymer for alkene. So let's look at polymer. A polymer, right, it's always a big monomer, a big molecule formed by many monomer, yeah. And the simple repeating unit is also known as a monomer. That's it. Okay, please write down. Alright, guys, now you see, whenever you have an alkene, always remember alkene can only form addition polymers. Remember this, alkene only forms addition polymer. And guys, the second thing is for addition polymer are non-biodegradable, yeah. Alright, guys, next. Why disposal of addition polymer is difficult? This came out in the exam before because it's non-biodegradable. That's it. Clear? Alright, guys, now. Yes, correct. Gloria, you're right. CO2H2 because of one carbon. Okay, one carbon connected to two hydrogen here. One carbon, two hydrogen. This will turn into a CO2 and H2O. Okay, guys, now let's look at addition polymerization. Crazy. Alright, guys, for addition polymerization, okay, what I want you guys to do, right? Maybe, okay, I want you guys to split it into half. Okay, so this, okay, always remember, yeah, so for addition polymerization, right, it's gonna be a 50%, 50%, okay, I call it as a 50% to 100% rule. Or 2 times 50% will turn into 100%. Okay, so remember, this is the rule, yeah, 2 multiplied by 50% is gonna be 100%. Okay, this just maths. So this is the rule in addition polymers. So guys, I'm gonna go for easier one first. I will slowly increase the difficulty, and this part is goddamn difficult. Okay, very difficult. I'll go slow. Okay, so guys, I want you guys to write it down. Let's say if we are forming polymers. Alright guys, how do you form polymer, yeah? Remember this, yeah? Okay, the first thing is always start from your C double bond C. Always start from the double bond. Okay, so please always start from a double bond. Second, please arrange any atoms or group up and down around the C double bond C. Okay, up and down around a C double bond C. Please remember, arrange it up and down. The step. Okay, please break the double bond. Okay, then convert to 250%. Alright, convert to a 250%. And guys, a 50% is a connecting line, remember that. Okay, the rule is very simple. Okay, so when you have a 50%, that is a connecting line. That's it. That's it. Okay, okay, guys, now I'll show you how to do for some easy question. But this time, okay, I'm gonna draw. Okay, so okay, I'm gonna start from easy one first, guys. Let's go. Okay, easy one's coming. Okay, guys, now, okay, I will show you how to do it. First step is to draw your double bond. Second, arrange the group and atom up and down around. Always remember, it's up and down, yeah? So one up, one down, one up, and the CH3 is down. That's it. Understand? Clear? And guys, whenever you see a double bond, this double bond, right, this entire line, this is 100%. Remember this. This is 100%. We're going to break this 100%. Okay, once you break this, you take a 50% to the left, 50% to the right. So it's going to turn into two tiny little connecting line like that. That's it. Okay, that is my polymer. Understand? So remember, when you break the 50%, when you break 100%, then it's gonna be two connecting line on left and right. Done. Okay. And guys, once done, any question? Okay, now I'm gonna show you another one. Guys, this time I want you guys to draw another one, but this time it's gonna be a skeleton. Okay, so guys, let's draw this skeleton. I want to train you guys on drawing skeleton. Okay, let's go. All right, guys, try it out. Okay, try to get me the answer. See if you can get it or not. The answer in skeletal, I want the answer in skeletal. Don't want structural, because structural is too easy. Guys, I will show you how to do it, yeah? Don't worry. First, always start from my double bond. I know that this is my double bond. I can start from my double bond. Okay, you see here, I start from a double bond. And guys, from a double bond, there's a one leg on the left, another leg on the right. I'm just gonna draw one leg on the left, another leg on the right. That's it. Okay, can see that. And guys, this is 100% line. When you break this, 50% go to the left, 50% go to the right, and turns into a connecting line. Connecting line, connecting line. That's it. Okay, so this time I will draw two repeating unit for you guys to see. Like that. Alright, can you see the two repeating unit? Don't wanna just do one repeating unit, two repeating unit, like that. Can see Okay, so or you can just draw like that, and it's the same thing. Or if you want to see two repeating unit, this is your two repeating unit. Can see this is one, this is two. Can see I'm just gonna put my answer like that. So these two repeating unit. Clear? Fine. Okay. Alright guys, last one. Let me show you guys something gay. Alright guys, again I always make question damn difficult to test you guys. Okay guys, try this. This is damn gay. Alright guys, this one right, just draw it out first. I don't think any one of you guys can solve this. Okay, I don't think any one of you guys can solve this, because in order for you to solve this, you have to be very good at breaking 100%, turn into a 250%. Alright guys, now let me show you how to do it. So first, guys, okay, I'm just gonna redraw everything. I'm just gonna paste it here first, because you have two, okay, because you have two double bond, right? Okay, guys, always remember, whenever you see a double bond, this one, right, this is 100% line. One more time, this is 100%. If you were to break this, it will always turn into 250% to your left and to your right. Let me, one more time, if you break this, it's gonna be a 250% to a left and to a right. So I'm gonna break this. You see, this one is 100%. This one is 100%. Okay, I'm gonna do it slowly. Okay, guys, watch me, watch me, watch me, watch me. This is damn hard. This is damn hard. So if you want me to repeat, I will repeat, but please focus, So I'm gonna start breaking the 100% now. See, when I break this 100%, it's gonna be a 50% to the left. Let's see, because this two carbon, right, and 50% to the right. Can you see that? Do you see a 50% line? 50% line. Get me? The same thing, I break this double bond, 50% to the left. This is the carbon, 50%. This carbon, take another 50%. So I break this, 50%, 50%, join back, a new double bond. Wow. So that is your polymer. Crazy, right? Alright, that's my answer. Can or not? Confusing, right? Okay, remember 100% turns into 250%. Yes. GG. Try one more. Try one more. Someone want try one more. You guys want try one more? Fun, right? Because I always increase the difficulty for you guys so that you can do it. Okay, try one more. Okay, all good. Okay, I will try one more later because we have a questions later. Okay, okay, I want you guys to try one more. Can I try one more with you guys? I think I can try one more with you guys. Don't wanna later. I give you try one more. Okay. Try one more. Try one more. Last one. That's it. Sorry, guys. If you hate me, also no idea. Because someone say try one more means try one more. Always remember, guys, once you turn into a polymer, right? Your polymer will only have two connecting lines. Will only have two hands. Remember, this will always be two hands. No three hands. You cannot draw three hands one. Turn it into 250%. Wow, I'm proud. Thank you. One kid got it right already. It's my water. Okay, my Joe boy already gotten the answer. Guys, whoever got the answer, you can send it to me. Or else I will start discussion. I have answer from Alex. Alex got it right. Well done. Thank you so much. Oh my God, you guys are getting it. I'm so proud. Okay, by the way, this is not discussed in school. I think it's discussed. Thank you, Amanda. You also got it right. This will never be discussed in school, but might come out in your exam question, especially in your paper one. Because this came out before. Shit, man. Yeah, I never taught my student how to do it. Yes, correct. All right, guys. I have Amanda's answer. Thank you, Amanda. Got it right. And again, I have Alex answer. I have Sun Long answer. Sun Long always get it right. Well done. So, and Joe Boy also got it right. I'm proud. Okay, guys, let me discuss. So again, I'm just gonna remember this. The rule is 100% turns into a 250%. Simple as that. Okay, so have my 100%. Oh, Gloria also sent it to me. Thank you, Gloria. Let me see first. Okay, I checked Gloria answer. Thank you, Gloria. You also got it right. Hey, you guys are getting better now. So cancel this. Okay, that's 100%. And it's gonna be a 250%. So this will be my connecting line. And another 50%. Right. I cancel this. And connecting line, alamak here. And 50%. So this will turn into a double bond, correct? Okay, so guys, it's a bit uglier if you were to draw it like that. So if you want to beautify your diagram, can. So let me show you how to beautify your diagram. Okay, I have one more chat coming in. Thank you. Alright, so guys, to beautify your diagram, okay, I can start from my connecting line first. Okay, I always start from my connecting line. Okay, done. I have how many carbon? 1, 2, 3, 4, 5, 6 carbon. Okay, so I can start from here. 1, 2, 3, 4, 5, 6 carbon. Then connecting line again. Okay, and double bond. Can see it's the same thing, right? Can see 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And 1, 2, 3, double bond. 1, 2, 3, double bond. That's it. Okay, all good. All right, guys, please ready now. We are moving on. All right, guys, now, okay, we're gonna do the reverse. So you guys know how to form a polymer? This time is getting a monomer from polymer. GG. Alright, guys. Just now, this is level 1. This is level 5. This is level 7. Okay, so if you can do 157 right now, let's look at level 8 onwards. Okay, like playing game like that. Yeah. So if you're stuck in level 1, then GG already lah. Alright, let's go. So guys, first step. I want you guys to find your repeating unit. So guys, your repeating unit will always from your backbone, will always be from the backbone. Okay, then second, identify your connecting line. Okay, so identify your connecting line and also a hidden connecting line. Sometimes you have a hidden one. GG, man. Okay, so identify a connecting line. Okay, that would be 50%. Okay, then third step, apply 2 times 50% back to 100% rule. So just now was 100%, turned into 250%. Now it's 250% back to 100%. Okay. Alright, guys, please copy this. I'm gonna give you a level 8 question, starting from this question. Alright, guys, please draw this. Alright, guys, come. Let me show you how to do this question. First step is to identify my repeating unit. Guys, can you see that this thingy, this thingy is repeated? Can you see that? So guys, first step, I just have to circle out a repeating unit. Can you see that? Can you see this thingy is repeated itself? Can you see that? Okay, so guys, first step. Okay, we draw a repeating unit. So my repeating unit does look something like that. Okay, you can draw any. Maybe I select this part to draw. You see, I'm going to select this and paste over. Yes, and guys, next is to identify my connecting line. Where is my connecting line? This and this are my connecting line. Can you see that or not? So I'm gonna do a purple color to show that it's a connecting line. Always remember a connecting line is a 50%. Get me? So now I'm just bringing my connecting line back. Bringing my connecting line back is gonna be like that now. Double bond. 100%. So you see how 50% back, 50% back, then 100%. Get me? 50%, 50%, 100%. Clear? Know how to draw? Fun or not? Very sharp, right? If you get the answer, very proud one. Alright, guys. Now, I'm gonna challenge you guys further by doing this question. Come, get me the answer here. Next question, please tell me A, B, C, D. All right, guys, that is a hidden. Thank you. Okay, guys, well done. All right, so whoever done, I'll show you the answer now, yeah. All right, guys, first is to identify repeating unit. This ding, that is my repeating unit, correct or not? Okay, I'm gonna draw out my repeating unit first, yeah. You see, a C, H2, C, H, double bond, C, H, CH2, correct or not? Connecting line. So guys, there is a hidden connecting line. Can see that? Okay, if you cannot find a hidden connecting line, now mind. So this is my 50%, this is my 50%, correct? So guys, remember when you break a 50%, it's gonna turn into 100%. So you're gonna bring this 50% back, 50% back. So this is not 100% yet because they are just a 50%, right? So you see, if I bring it back, it's gonna be like that. 50%, 50%. Can see GG. I have two 50%. Okay. Then how do I complete? You cannot have a diagram with just a 50% bond. Okay, do you see 100% here? So this 100% can also go 50%, 50%, right? So once I break this bond to a 50%, 50%, and boom, my final answer, it's like that. You see, break 100%, 50%, 50%. You see a double bond, C double bond C, C double bond C. That's it. Donkey. Fun, cool or not?
Next one.
Huh?
Let's go to next one.
Next one. Next one is level 10. Okay, I'm gonna show you level 10 question how I do. You think it's D? Oh, so fast,
No, because I did this one instead of this.
Oh, okay. No, not bad. One more. You guys love it, right? Okay, so guys, so that's why you see I cannot move on fast, and that's why you see I will definitely be slower than your school because I dive very deep into a question. So bear with me, if I go slow, don't worry. Okay, I'm pretty sure I can complete everything before your AS, but I need to go slow because sometimes I will discuss some very difficult part. All right, guys, now, yeah. So I think I'm very, way, way, way slower than your school already. GG, man. All right, now I'm gonna give you another one. Kid, the second type of question, right? Okay, is when you have, okay, I want you guys to draw this out. Okay, I will level up again, yeah. So this time it's gonna be way harder now. Walala. All right, guys, let's look at this question. Okay, guys, my question is the polymer, this polymer is formed from 2 monomer. And I want you guys to find it. Okay, so this polymer is formed from two monomer. Let's find it. Okay, got the answer? Alright, guys, let's go. Okay, so long we join. Alright, guys, first identify your repeating unit. I will say this is my repeating unit. Okay, so please identify your repeating unit first. Okay, then guys, I'm gonna start redrawing it, yeah? And the first thing is to find a connecting line. Correct or not? Okay? So guys, next, connecting line is always a 50%, yeah? So please bring it back to the left, bring it back to the right. Okay, so one of it, you see, right, guys, if I cancel this connecting line, I can either add it to either this carbon or this carbon. But your connecting line cannot be here lah, because it's way too far already. Try to bring them closer to your backbone. So just now, I cancel here, my connecting line can be a 50% like that, a 50%. Just a 50%, yeah? Then this is also a 50% line, bring it back to a 50% like that. Can see. So which means, guys, there should be another connecting line that is hidden somewhere that you cannot see. Where is your hidden connecting line? This is our hidden connecting line. Because once you break it, then the 250% is going to get completed, right? So I bring this to the left, I bring it to the right. So eventually, what's going to turn into? See ya? It's another thingy. Bye-bye, connecting line. Bye-bye. Yeah, shit. And 100%. 100%. Done. Fun or not? Very fun, right? If you can do it, it's very fun one. But if you cannot get it, then GG already. How? Fun or not? Like playing game like that, right? Alright, guys, next. Do the last question. And after that, we are moving on to a brand new chat. We have 30 minutes left. I want to move on to chapter 15 now. Guys, I'm sending chapter 15 over to your chat. Please download it right now. Okay, and also uploading it on Portal. So whoever is using the Portal, please. Hi guys, please download the new note here. Yeah, I get it for you. Give me a minute. All right, guys, do the next question, and after that, download chapter 15. We are moving on to chapter 15. Fun or not? All right, that's it. Okay, guys, now last question. Okay, first, identify a repeating unit. This entire thingy is repeated, correct or not? So, guys, now I just have to copy and paste. Oh my god, what the hell? Convert to ink. All right, so guys, first thing is, well, this is a bit big. Find my connecting line. Connecting line, connecting line. Correct or not? Alright then guys, break the connecting line back to a 50%. So you see, I'm breaking it and 50% it. 50% and cancel 50%. Correct or not? Alright, so remember it's just a 50%. Alright then guys, oh my gosh, the 250% is way too far. So I can find another connecting line to complete it. Alright, next. After that, this is your connecting line. You can see that. Guys, if I break this connecting line again, so this is 100%, break it to the left, break it to the right. Oh shit. Okay, can Alright, so guys, do you see my propane is here already? That is a propane, right? So this is the thingy that we are looking for, but the thing is, it's not completed yet, correct? So, hi, how do you complete the 50% again? Another hidden line is here. Oh my gosh. Bring it to the left, bring it to the right. Correct. Go. Final answer? 100%? 100%. Ding, ding, ding. So your answer is 1, 2, 3, 4, 5, 6. 2 double bond, 4 double bond. 1, 2, 3, 4, 5, 6. 2 double bond, 4 double bond, and booyah. Whoever got D, I am super proud. Kinda fun or not? Quite fun, right? This lah. Alright guys, with that said, we are done with the hardest chapter in organic chemistry, alkene. FYI, alkene is the hardest, yeah.